Okay. Logistic growth.
This new one.
Why? This is new.
Max.
Yeah, I hope the game went well. So, just backing up, exponential growth. Exponential growth is not very reasonable when looking at real world problems.
So why?
Okay, like population growth. Does population growth make sense with exponential? No, because eventually there's going to run out of food, right? So what it looks like, right? So logistic growth will look like it's exponential, but then it will level out and it will have a horizontal asymptote, okay? Because, you take a population of deer or something like that, and it gets bigger and bigger, but then the food runs out and they die, right? They starve to death. So
this brings me back to Mr. Christopher Age. We looked at the graph of like deers and wolves. And
yep, we'll have that in this lesson. Okay, but before we do that, we have to do something. It was back in pre-calc. I don't know if you remember partial fraction decomposition.
No, I don't even know what that is.
So we will review it as if you've never seen it before. Okay, so basically what we want to do is take the fraction apart. Okay, for example, let me give you an example of, let's say it was 3 over x plus 2 plus 2 over x minus 3, right? So I could actually take the integral of each of these, right? I can integrate this. It would be 3 natural log of x plus 2 plus 2 natural log of x minus 3. But what would we do if we had to combine all that? We would have to do what? We'd have to multiply this by
log times log.
Right? We would have to multiply this by x minus 3. So we'd have what? 3x minus 9?
Yeah.
And then we'd have to multiply the second fraction times x plus 2. So this would give us 2x plus 4 over x squared minus x minus 6. So we would have 5x minus 5. Okay, so basically what we're going to look at in this lesson, let's say I had to integrate this, 5x minus 5 over x squared minus x minus 6. We can't factor that. We can't do u substitution. We can't do...
So you have to split it up.
So what we want to do is work backwards, and we want to figure out how to write it in this initial form. That's partial fraction.
Aren't there so many options?
There's only one option.
You're starting at 5x minus 5 over x squared minus x minus 6?
Yeah, but what I'm saying is you're starting with this, and we want to work backwards to get to the...
So looking at A, you'd have to factor the
Yeah,
bottom.
because the part in blue, I can integrate this easily. The one I highlighted is not so much. Okay.
So at some point we're going to have to unfactor it. And
Yeah.
then we're gonna
So
have
here's what we're going to do. So take a look at the bottom. How's that factor?
X minus 2, x plus 3.
Good.
X minus 6 is 6.
It doesn't matter which order. Okay, so I want to make one of them into x plus 3, and one of them is going to be x minus 2. And I have to figure out what a and b are. Okay. Ignore what we started with.
Oh, I have a
Should we
What would you
divide by...
do? What would you do to find a common denominator here?
multiply.
I would multiply a times x minus 2 and b times x plus 3, right? So it would be a times x minus 2 plus b times x plus 3 all over. Okay, we agree with that statement? Now I'm showing extra steps for right now. We'll shorten it. So what has to be true? The a times x minus 2 plus the b times x plus 3 has to be equal to 2x plus 16.
But I'm still left with A and the B. So
Right, so now this is true for all reals. True for all x as long as, okay, so this is going to be true for all reals. Good? Okay. So what we're going to do is we're going to get one of these terms to cancel. So if it's true for all x, what happens when we let x equal 2?
A cancels out.
Yeah, and what do we get?
Which is 5b.
5b equals
2x is 16 over
20, which implies b equals 4.
Then we do the opposite, so b equals
Okay.
-3.
So now let's let x equal -3. Okay, so -3. So that'll be -5b equals
18.
or -5a equals 10.
Yeah.
Which implies a is -2. So
So it's going to be -2 over x plus 3 plus 10 over x minus 2.
yeah, -2 over x plus 3 plus 4 over x minus 2.
That's a lot of writing.
Yeah, we're not always gonna, you'll see. Not too bad. So now, the whole point to this is we're leading to integrating, so we can integrate this easily. Okay,
Oh,
So-
and the next step is integrating.
so what do we have? We're gonna have a over x plus 3 and b over x minus 3. And you know it doesn't matter which one's a and b. Okay, so I'm gonna make this a little bit shorter. So I have a times x minus 3 plus b times x plus 3 has to equal 3. And some of this we can just do in our head, right? So if a is 3, or sorry, if x is 3,
B equals 1/2.
b is a half. And
-1/2.
a is -3, so that'll be -1/2.
So you left with
-half over.
-1/2. Oops.
so -2x. So a equals, it's -1 over. -1 over 2x minus 3. No.
Oh, just multiply, when you, right, you could just multiply the bottom by 2. Honestly, I'm not picky about this, because if I were to integrate this, I'd actually leave it with the 1/2. It looks kind of ugly, but it's easier. Because otherwise, if you do this, you have to do u substitution here.
Or you can just do the, because u is a constant, or d is a constant, so you just divide by the constant.
You just divide by 2. Yeah.
You know, I think I generally see a fraction in a fraction of 1/2 over x plus 3. I think those little stacks of pumpkins that they fall, you know? Like, small.
Oh, yeah.
Do you get
Okay.
it? Do you get it though? Like, I don't know why.
I get it, but.
Like, it looks like it's like a pumpkin and a smaller pumpkin, like, you know?
Yeah. Okay.
Pumpkin.
Pumpkins. If that helps,
You hear that, Max? Just think pumpkins.
just think pumpkins, Max. Okay. All right. First, we have to. So now this leads into. So are we good with partial fraction decomposition?
I'm
It
good.
sounds really messy. It's not. I promise. Okay. Let's take this and rewrite it so that we can integrate it. Because again, the hardest part in like chapter 7 and then chapter 8 is you look at something that you have to integrate and you have to go through all the different ways to integrate. So like u substitution won't work, right? You can't just do straight integration. There's nothing we can do to simplify this. So then we look for, can it factor? This is, so we use this when the denominator is factorable, which is x and x plus 7. So over on the side, we'll do a, yeah.
Yeah, general. Yeah.
I thought I pressed it, but sometimes. Right. So we have a times x plus 7 plus b times x equals 5x plus 14. So let's see what a and b are equal
So
to.
A is equal to 7a equals to 14, so a equals to 2.
A equals 2. And b, we make it 0.
Would b be negative 7? So negative 7b equals negative 35 plus 14.
Oh, wait a second.
So b to I see negative 7. Negative 35 would be 14. 21. Negative 21. So it would be 3.
3.
Hey, that's
There you
pretty
go.
good.
I mean, if you need to write it out, that's fine.
Write it out.
Okay? All right, so back up here. So now that we have this, we can rewrite this as the integral of 2 over x plus 3 over x plus 7. Now it's much easier, right? Because we can't integrate it otherwise. And let's make sure to throw in some absolute value just...
Now it didn't. Now it didn't do it, right?
Yeah, so 2 natural log of x
Oh, that means you could.
plus 3 natural log, or sorry, forgot my natural log. Said it, but you don't have to worry about u substitution here because
Pretty obvious.
the derivative of the bottom is 1 in both cases. Plus c.
Ooh.
Ooh, of course.
Uh-oh.
Of course forgot
Should
it.
we forget that?
Surprise.
Thanks, Jonah.
Good.
Why not?
Can you try this one out, Jonah?
Yeah, I'll try.
Okay, here's marker. You open board.
Factor?
Be 3x. Well, that'd be minus.
It has to be both minus,
Yeah.
right?
Two,
2 and 1, 2
2x
and
minus
1.
1. I got it first.
You think?
Said it first.
Because she wrote
I-
it first. She wrote it first. That's why
Did I?
wrote it.
Yeah.
I was looking down at my paper.
Okay. And then we just have to figure out A and B. All right.
B equals negative 2. Okay. 1 minus 2.
Negative 2.
Negative 2, yeah.
And A equals 3. And B equals negative 2. Yeah, that's right.
So now you get the integral of
So now we have the integral.
3 over 3x minus 2 plus negative minus 2 over x minus 1 dx.
Okay.
Now we've got
Okay, so now it's going to be
3 ln
3
dx
natural
minus
log of
2.
3x minus 2 divided by
by
3.
Yeah.
So we're just going to have natural log, right? Because we'll divide by 3 and that will cancel.
Where's the 3 and negative 2?
Well, here, you would have a 3 in front, but then backwards u substitution kind of stuff, right? Backwards chain rule, that is. You have to divide what's the coefficient of 3x minus 2. 3, so that's what we have to divide by. And this one's just going to be minus 2 natural log of x minus 1.
And you're dividing by 1 just secretly.
Yep.
Very secretly.
Hmm?
Secretly.
What's secret?
Exactly.
Good? Are you throwing markers?
I'm not throwing markers.
Okay.
Quite the contrary, actually.
Oh, there's an extra parentheses here for some reason.
Parentheses. The record show that that is an apostrophe.
Apostrophe. Thank you. I'm sorry. Last period. I know the difference. Okay. Don't forget there are other methods. So there's some of these sprinkled in the homework. So when you first look at it, don't just automatically assume it's partial fraction decomposition. However, you can do both. Can you factor out x squared minus 1 and do x plus 1, x minus 1?
Yeah.
Yeah, but it's so much easier to just use substitution here.
You get 2x. Yeah.
You'll get the same answer in the end, right? We would let u equal,
So that's how you can waste
So
your
what-
time on the.
Kind of say that. is this
yep,
gonna be-
that's why it's going to be really
Can I look
important.
at it and say ln is going to be ln of x squared minus 1.
No.
I guess.
Do you need work for that? Or?
Not really, because here, well, mainly because I laid it out pretty nicely for you here. So, right, because it's going to be 1 over,
Let's see though. Don't get that. So, does Max have to watch this whole thing, or does he get 10 minutes when he asks?
no, I'm recording. We're at 15 minutes and 48 seconds.
Good luck, Max.
No, but he can also like fast forward through parts. That's what happens when you watch it from class. So like he can fast forward it right now because he doesn't need to hear this conversation. But then he might miss something that we say.
Exactly. He doesn't know.
Sometimes I put it on like
Yeah.
twice speed. Like,
Yeah, definitely.
Yeah, I'm okay with that. I like to really like hear what's going on.
Okay, 2x cubed over x squared minus 1. Any ideas? It's something we have not done at all this year yet.
So I
You
don't
would
know.
be.
Something you learned all the way back in Algebra 2,
Oh.
long division.
Oh no!
Oh.
No.
We actually
You're so
did it.
funny.
You actually did this. Do you remember doing long
I
division?
hated long division.
Okay,
I
let's,
really remember.
come on, it's not so bad.
I very much was not a fan.
Okay,
Why don't Matthew just do like division symbols that way, like the weird curvy one?
I keep writing as a radical.
Oh.
I do that all the time.
how do you make a long
I
division?
just
I copy these. I do it like this, like a straight.
Oh, nobody's picky about.
I used to do it.
Long divisions.
Dude, rad.
Okay, x squared goes into 2x cubed. 2x times?
I don't know how to.
Yeah, 2x.
I don't get it.
Just imagine that you're basically dividing this by x squared, because you're dividing this into this.
X squared is x squared. X squared is because it goes into.
Because remember, when
it
you,
goes into the x cubed part.
right, and when you multiply it back out,
2x is remaining.
right, I do the draw the line, change the sign, and combine, or you can subtract. I know, I do that on purpose.
Oh my.
Draw the line, change the
Right.
signs, and combine. Now, it doesn't go any further, does it?
Draw the sign. Change to combine.
2x over. Okay. Now, I conveniently gave you the 2x over x squared minus 1 on purpose. It matches the one above it. Otherwise, you'd have to go through u substitution here. But I intentionally gave you. So now we want to integrate 2x plus 2x over x squared minus 1. And that equals
X squared.
x squared, and then plus what we got for that last one. So we don't have to go through that mess again.
What did I? Oh. Let's see.
Okay, now that's all I actually had planned for today. If you want to keep going or you want to take the time to work on homework.
Let's keep going.
You want to keep going?
Does that mean we have extra homework, or like we'll just go until
No.
we do the homework until we, or just do the next homework tomorrow night?
Occasionally in BC, we do the whole lesson and then we have the next class to do homework, because sometimes the homework is where you have more questions. It's fine. I'm fine with it.
Good.
Okay, so I briefly talked about this logistic equation, right? So it has to it has a shape that looks exponential, but then it has this point of inflection. That point of inflection, right, where it changes concavity. So it's like concave up and then it changes to concave down. And it will have a horizontal tangent here.
Can I just run to the bathroom before the lesson?
Yeah. Should I pause it? It should be. Well, you haven't learned it yet, but you know,
Oh, no.
we're getting there.
I get it.
Okay, hopefully this looks familiar because this was the last lesson. This would be for some population. So it would be like P equals P naught E to the KT. That's really what that is. Okay. This is how a logistic differential equation looks different. Okay, so we got some new vocabulary. We have vocab. Well, P is just the population. Okay. Carrying capacity, that's M. Okay, so M is our carrying capacity. That means that's the most we can have.
It's all repopulation.
Carrying capacity, right? So that's the most that, if you're talking about like a population, that's the most that you can have. P is the population at any time. K is the rate of growth, so K is still the rate. Okay. So here's what we're saying. We're saying that the rate at which the population grows with respect to time is equal to, or is proportional to, K is our constant, right? Times the population, times the limiting factor, which is your carrying capacity minus the population at a point in time.
Population times rate
Yeah.
times carrying capacity minus population.
Right, so the whole, you see this one is just K times P above, right? So there was no limiting factor. So now we're multiplying it by that limiting factor.
Somebody's holding it back.
Yes. Okay.
Thank you, RN.
All right,
Notice that.
You're my limiting factor.
here we go. We got bears.
Good.
Okay, bears in a wildlife preserve is modeled by this differential equation. Okay, so let's see. Compare that to the one above. Okay, so what's our K? Let's just identify.
0.008.
Okay, so there's our K. P is P is going to be that variable. And good. This is our M, which is the carrying capacity.
So it's just 100.
So it's just 100 bears. Okay, what is the population when the population is growing the
But
fastest?
how do we say fastest? Like, what if there's no value?
Okay, hold on. Okay,
It's when it's increasing the most.
so that means we're going to do the derivative. Okay, this is the rate of growth. We want to know when is that growth the fastest.
You
So,
do the derivative.
We want to do the second derivative. What I would first do is take this, distribute. It'll just make it easier. Actually, you don't, I'm going to just multiply it. 0.8p minus 0.008p squared. So in other words, we're looking for the critical point for the second derivative.
Yeah.
Okay, so that's going to be 0.8 minus 0.016p. Okay,
After that.
so we want to set that equal to 0. $50.
50.
Okay.
That's what I meant.
How do you 50?
Um,
Because 8 is
0.8 divided by
is
0.06.
actually bigger.
Oh, yeah.
Okay, so 50 bears. Now, that's not an accident.
Halfway.
It's halfway.
All
Think
the
about
way
your
down.
logistic. Go back here. Look at the point of inflection. That's when it's the steepest. So that point of inflection is the halfway point. Okay. What is the rate of change of the population when it's growing the fastest? So now, rate of change of the population.
So you just plug in 50, right?
Right, so we're going to plug in. So when P equals 50, we want to find dP dt. So that's going to be 0.008 times 50 times 100 minus 50.
So I'm not equal to that.
I got it.
It's a nice even whole number.
0.008
Yes, she has a nice even whole number. I'm saying 4.
Not 4. How about 20?
Okay. I was close.
Okay, what is our rate?
1 digit off
20 what? What does
20
this mean?
bears per
per
year.
Yeah.
Ooh, whoa. Big yield.
So that means the carrying capacity is 100. When there are 50 bears, the population is growing at 20 bears per year. So after that point, it will slow down because we're running out of food, all that kind of
You know,
stuff.
Are you bear son?
Yes.
Okay.
I'm more of a Cubs fan.
That was pretty easy, right? So far? Okay,
Knock on wood.
It's always
Okay.
gonna get harder.
it's always gonna get harder. It's fine. Okay. Yeah, this is the last lesson. That's why I said we're gonna have 2 days. Well, I don't know if we'll actually be able to finish, but okay. Now what do we have? Oh, we have the Michigan Department of Natural Resources had to airlift 61 moose.
Did they?
I don't know.
What else but moose? There's no moose.
It's moose.
There's no mooses.
Mice.
It's like deer. Moose.
Sheep.
Mice.
Mouse.
Sheep. They say sheep.
Moose, mice,
Okay.
Beef.
or
They say,
mooses.
instead of cows, just
Okay.
beef.
Moosey.
They said that they would reach a carrying capacity in about 20 years. This is our growth rate.
I mean, that's how many they can. That's how many moose they can airlift.
No, they already airlifted 61. So they're
Okay,
taking
capacity.
61 moose and they're putting it in a preserve. And they're saying, okay, we only have about 25 years until we reach that maximum, which means we either have to relocate them at that point,
Or
right?
hunt.
These are actual real
Or
questions
open
for
the
preserve.
hunting.
Because sometimes when animals grow beyond their carrying capacity, now you have to find a new home for them, you
Or
know?
just
And if
open
it's
the
a preserve for something that's
Do they do this in zoos too, or no? Because
No.
not a zoos, mostly reserves.
They'll airlift.
Because they want to make sure that, especially if it's an endangered species, that they don't start, right, dying off at a certain point. We want to make sure that they have a place to live. So according to the model, what's the carrying capacity? 1,000. So there's 61 moose. So they're saying in 25 years, they'll be up to 1,000. Okay. With a calculator, generate the slope field. We just were looking into that. I'm going to say we can skip it for now because it's not really going to help us in any way. Solve the differential equation with P of 0 equals 61. Okay. So, remember this thing that we're starting with here? This is probably the last thing we'll get to today. So in other words, we have to solve for P. What's the first thing we do? We move the dt to the right side. What's the second thing we do? We move all the variables. Okay, so here's what I'm going to do. I'm going to leave that 0.0003 on the right side, and I'm going to do this. You see a partial fraction decomposition coming up? I know.
I already forgot.
Okay.
I mean, we kind of just learned it. So.
It's fine. We just learned it. Okay.
Let Jonah.
Let's just take this piece for now. So A over P plus B over 1,000. And every year I tell myself I gotta give you guys more room, and I don't, and I'm sorry.
So,
Okay.
We forgive you.
Yeah, you should. Okay, so we have A times 1,000 minus P plus BP equals 1. That's just pretty easy though.
So when P equals 1,000.
They're both the same.
Yeah.
1 over 1,000?
Oh.
Yeah?
Yeah.
You can also write that as 0.001 if you want to write it as a decimal. Okay. Okay so far?
We'll say yes.
All right. So here's what we want to do. We're going to integrate. So I'm going to go from like this line here. We want to integrate 0.001 over P plus 0.001 over 1,000 minus P dP. Okay, so we have 0.001 natural log of p plus 0.001 natural log of 1,000 minus p divided by -1. And I know. Okay. You know, when you first, you probably don't remember this, but we did the long way back when you first did differential equations. Then you get to go to the shortcut. Okay. Now what? What do we have to
So you
solve for?
you plug in.
P of 0 equals
P of
61.
0 equals
61.
61.
So it'd just be C equals whatever that is.
Yeah, it's not that simple. Also, we can also, if you want, multiply everything by 1,000. That will just get rid of all of our decimals. You know what I'm saying? So if I multiply everything by 1,000, I'll just have natural log of p. Oh, let me change that to a minus. Minus natural log of 1,000 minus p equals well, t is 0 anyway, but when I plug in 61, I'll just get 61, and then that's 939. So it'll become natural log of 61 over 939. Okay. 310. And we're running out of room.
We need to order the test that way.
Well, here's the thing. We have to go from where?
All the way back.
We can plug it in here. But what are we trying to do? We're trying to isolate the.
Oh boy.
Send it E.
So, okay.
So I'm been out of space for a while.
Okay. I know this is the only time I make you go. If you want to just pay attention, and then I'll show you. So if I do natural log of p over 1,000 minus p equals 0.3t plus natural log of 61 over 939. No.
So you didn't do E, there would just be P over 1,000 minus
But you're down. Then you times 1,000.
If okay, what I would have done, here's what I'm going to do. Oops. Why would I do that?
Good question. Why did you put a negative sign there? I could not tell you.
No, because you're doing the second ln divided by.
Right, and I'm trying to isolate p. So now I can move the negative over here, and then I can do e to both sides. So I will just show you the result to save us all some time. And then I can show you next class if you want to see how I got these exact numbers.
Wow.
Okay, in the homework, I specifically said, and we'll do more examples because I split the homework up in two.
I'm assuming the first I tell
Yeah.
you do not need drive by hand. So.
I'm actually glad we did
What
that.
we just did, we derived by hand. You can go to the shortcut. I think I only assigned stuff with like the population growth though. Okay.
Thank you.
All right, guys.
Tomorrow.
So see